Well, guys, today we have again come with some very advanced problems. This problem is done in 2007, as you can see on the screen. It says positive and negative point charges of equal magnitude are kept at 0, 0, a by 2 and 0, 0, minus a by 2. So let us first draw a figure. So this is your x-axis and this is your y-axis. And this is your z-axis. Now, positive charges are kept about this is 0, 0, a by 2. This will be your 0, 0, a by 2. And this will be your 0, 0, minus a by 2. We can name this as P and Q. And in the question, positive and negative charge means here positive charge is there, here negative charge. Then it says work done by the electric force when another positive point charge moves from distance. So let us name this point. This is A and this is B. And this is basically minus A, 0 and 0. And this is plus A. Now we are moving positive charge from A to B in the electric field of this, the charges at P and Q. So this is a problem related to work done. And in such problem, it is better to find the potential at A and potential at B due to the charges at Pn. For finding out the potential, we require PA and AQ distance. So, what is PA? PA, you can write it as A square spring. And this will be basically root 5A by 2. Likewise, your PB will also be root 5A by 2. Correct. And PA is your strength and AQ will also be same thing if you find out. All these distances will be same. So what is the potential at A? Potential at A will be, let us see, from the charge kept at P, that will be Q upon AP or PA, that is root 5A by 2. And what is potential at A due to the charge kept at Q? That is, and it is basically minus this, and this distance will be your same. So here basically it comes as 0. In the same way, if you find potential at B, it will also come at, means potential at A is equal to potential at B. That means what? It means if you move a charge from point A to point B, then since both the charges are the same potential, there will not be any work done. Because electrostatic forces, they are conservative forces, and work done by them do not depend on the path. Correct? Now, in this question, if you see, charge at P is plus Q and charge at Q is minus Q. Even if both the charges are either positive or negative, then also potential at A and potential at B will be same, because these distances from A and B, like AP and AQ and PB and BQ, they are all same and charges are also same. So here your answer is basically 0. No work is required to do that. To move a charge from A to B. I hope this is correct, and this, I hope you understood this problem. Correct? Now let us take a look at this another problem. This has also come in IIT JEE in 2002. It says two equal point charges are fixed at x is equal to minus a and x is equal to plus a on the x-axis. So let us see. Let us draw the figure first. This is your suppose origin, and this is plus, and this is your minus. We can name this point as A. We can name this point as B. Your Q charge is at basically at the origin. Now, change in the electric potential energy of Q when it is displaced by a distance x along the x-axis. So let us see, we displace this charge here, and this point is suppose O dash. And this distance is basically x. Correct. Now we have to find out the change in the electrical potential energy. Our figure is something. How we can find out? Again, in the last problem we have seen, we found out the potential. Here also there are two charges at A and B, like one is Q and C. Both are equal. Let us find out the potential at O initially due to this point charges A and B. That is VO we can write Q upon, it is your A plus Q upon Q. Correct? Then this is basically Q upon Q. I hope you understood this. Potential is a scalar quantity. We have to take the distance between the coil and the charges. Right? Here both the charges are positive. That's why the potential due to charge at A and charge at B, they will have to add up. Correct? Now, let us find out the potential at O dash due to the shifting of the charge. So here it will be basically Q upon one distance will be basically, you can say A plus X. Another distance will be A minus X. Or you can say A Q 2A upon A square minus X square. Now, let us find out the change in the potential energy. Change in the potential energy. What is the final part? Because your O dash, when it's Q into VO dash minus Q into V. And Q you can take common. Here, K also you can take common. Q also you can take common. Then, what remains? Q, K, Q you have taken common. Then here it remains 2A upon A square minus X square minus 2 upon A. Or you can take 2 also common. You can take 2 also common. And you just simplify it. Correct? When you simplify it, you will get X square upon A square minus X. Correct? Now, in the question, we have to find out this proportion. The change in potential is proportional to this. Correct? So, if we approximate it, since your X is quite less than A, it's a very small distance. Then we can approximate it to Q, Q, A, Q upon X square upon A, Q. Of course, here it will be A also, it will be common. Correct? So that means delta U is proportional to basically X. The change in potential energy is proportional to X square. I hope this problem you must have understood. Correct? Now, we will take a look at this problem which has come in 2001. It is JEE Advanced problem. A uniform electric field pointing in the positive X direction exists in the region. So, let us see. Let us draw a uniform electric field. It is pointing in the positive X direction. Like this. Then it says, let A be the origin, if A is the origin, and B be the point on the x-axis, and x is equal to plus. And then C be the point on y-axis. This we can do. Then potential at point A, B, C satisfy this thing. As we know, this portion actually It's very simple. We know minus E is what? Minus PV upon VM in this one. Or PV means the negative gradient of the potential is in the direction of the electric field. Means in the direction of the electric field, potential decreases. Correct? In the direction of the electric field, potential decreases. Means let us go one by one. VA is less than VD. No, because in the direction of the electric field, potential is decreasing. That means VD will be less than VA. In this point is not. VA is greater than VD. Of course, it will be there. Then what is VA is less than VC. Now, VC electric field is in the direction of the x-axis. So, potential with the perpendicular to x-axis, it will not have any effect. Correct? So, if you see AC is the basically equipotential line. And that way you can say VA must be equal to VC. If this is not correct, here this is also. So we have only one answer, and that is B. Your VA is greater than. I hope you understand. If you know the concept of potential energy, relationship between potential energy and electric field. Correct? Let us take a look on the another problem. This has also come in JEE Advanced. This dimension of the 1 by 2 epsilon E square, where epsilon 0 is the permittivity of the free space and E is the electric field. Yes. So this is a very simple problem. What is this basically? What you have to see what is this. If you remember, this is energy density, that is V. What? Energy density. Energy density is what? Energy per unit volume. Correct? If you know this much, you can answer this, because the dimension of the energy, you know, dimension of the energy is what? Energy is what? Work done. Work is what? F into R. Correct? What is F? Is force. Force. What is the this M into A? M T minus 2, which is force, into M. This is what? This is your energy. Energy per unit volume. Yeah, this is that energy, right? Yes. G or half epsilon 0. So what will come out? This will come out as M minus 1 T minus 2. Correct? Yeah. Very simple question. Let me tell you the simple questions which were asked earlier in JEE Advanced. If you see the pattern of JEE Mains, the same questions are being now as in JEE Mains. The old JEE Advanced questions, they are being asked nowadays in JEE Mains. So even if these questions are old, see they are very important from the point of view of the JEE Mains. Correct? So this is another problem which has come in 1998. This problem says a charge plus Q is fixed at each of the point x is equal to 0, x is equal to 3x0, x is equal to 5x0 on axis, and minus charge is fixed at x is equal to 2x0, x is equal to 4x0, like that. Here, x0 is a positive constant. So let us, first of all, let us draw a figure. So this is your F-axis. Question says, this is x0, this is 2x0, 3x0, and so on. And you have charges at x0 plus q, here minus q, then plus q, minus q, and here plus q, minus q, like that, till infinity. Correct? So we have to find out the potential at origin. Potential at origin, what would be potential at origin? Q, J, Q upon x0 minus q upon 2x0 plus q upon 3x0 minus q upon 4x0 and so on. This will be the series we will be getting. Correct? If we make a formula q upon x0, then we can write this thing as 1 by 1 minus 1 by 3 plus 1 by 3 minus 1 by 3. Like, correct? Now, mathematically, if you see, if you find out the sum of this series, mathematically, then you will write this into log. I will not be going into the mathematical details. The mathematics also we are studying. So let's find out the series, the sum of the series will be log. Here we find this answer. And here this. Correct? I hope these questions were relatively easy. They are old questions which have come in JEE Advanced. But as I told you, these questions are important for the JEE Mains point of view also. So you go through all these questions and think about the other similar questions which can be made out of this concept. So here, for this video, this is for all. We will again come with the JEE Advanced problems in our next video. If you like this video, please do subscribe my channel. And if you want to ask any doubt, you can always ask your doubts in the comments section. You can WhatsApp me. My number is always there in the channel for any help with the physics. Guruji online is solidly dedicated for physics only. So you can look forward to Guruji online pages for your preparations for various competitive exams. Correct? We have generally the videos in English languages only, but very soon we will be coming with the Hindi version of the videos also. Okay, so let us stop here. Just go through this video. If any doubt is there, if you want to say anything, please do say in the comment section and watch something. Thank you very much and enjoy your Sunday.